Hello, everyone. Hopefully you can hear us right now. We are getting started here. Devrez and myself are really excited to be with you. Today we'll be focusing on tackling geotechnical headaches from our side, and really thank you for your time and joining this session. What we'll do is we'll start with our presentation. Feel free to add any questions you have within the Q&A along the way. We'll be happily answering those questions, leaving time at the end of our presentation. So with that, let's go ahead and get started. Devrez, what do you say?
Great. Thank you and
Perfect.
welcome everybody.
Yes, great to have you here. Well, first, we'll do some introductions of ourselves so you know who we are. Just to begin, my name is Kimberly Norton. I'm the head of sales at GeoDin, and my background really is in the commercial side. So I have worked for startups in the past, specifically focused on bringing software into new markets, and have really been enjoying my journey with GeoDin for a little over about a year and a half at this point in time. And with that too, I'm well balanced out on more of the technical side with my colleague Devrez. Devrez, let me let you do an introduction for yourself here.
Thank you. Welcome everybody. My name is Devrez Karabacak. I'm the head of product for GeoDin. I've been with Fugro 11 years. I have a background in data acquisition and analysis techniques, and I've been introduced into the world of geodata over a decade, and I'm really enjoying it. I'm really learning a lot, and I'm really excited about what we're doing with GeoDin on tackling some of the geotechnical challenges of the industry.
Absolutely. Thank you. And Devers, with that background and your tenure at Fugro, there's no one better to speak to Fugro and what we do than yourself. So please take it away.
Thank you. Well, for those of you who are not familiar, Fugro is a global company. We're the world's leading geodata company, as we call ourselves. We do all sorts of measurements around Earth and geodata and geoposition data with the mission to create a safe and livable world. We have about 11,000 employees spread across the globe, operating over 55 countries. We're about 60 years track record, and so we have a great knowledge and depth about geodata and geotechnical data investigations. We operate in three industries in particular: the water industry, the energy, and the infrastructure. And with geodata, we're trying to tackle the world's challenging problems around climate change, urbanization, increase of population, and of course, energy transformation, as you're all familiar with. These are sort of the societal challenges where we feel geodata plays a key role, and we are happy to be part of that.
Great. Thank you, Deborah.
What do we do in Fugro to make that impact? Well, we actually do mapping, modeling, and monitoring of Earth. And we do this through various techniques, whether that's from satellites to airborne planes and drones, all the way to vessels in the water and trucks on ground. We drill at locations. We sometimes scan at other locations. We sometimes remove samples from investigation target locations, and we send those to laboratory for analysis. The idea is all of this data comes together for people who want to plan, build, and operate infrastructure around the world. And geodata is a key part of that because we do not want any risks associated with that infrastructure, any uncertainties, and of course, costly delays and overruns should there be surprises about what is in the ground for where you want to execute your project on.
Great. Now let's dive in a little bit into our presentation at hand. And we want to, I know this is a little hard because we're remote, but maybe what you could do is do a raise of your hand. You can see that at the top bar for many of you, but we want to know who can relate to some of these geotechnical headaches. So first, Devers, if you don't mind clicking, we'll bring the first one in. Is that all the data that we need, right? Really, that issue of ensuring you have all the data on hand that you need, because it can be really hard to determine that. And it's always pretty complicated when that happens at the end, when you're already getting to the point of design, right? So that is one that we've heard. Another one that I know is pretty common, I feel like a dinosaur. Why am I still processing PDFs? Devrez, this actually just came up for us today on a call where we were talking about this. And Felix, I see your hand raised here. Thank you. I know this is something it's quite common with PDFs. Devrez, do you want to add anything since I know this has been a sore point for us even in conversations today and meetings that we're having?
I think PDFs is a great format for generating a digital printout of your end conclusion, a static image of essentially what you have generated as a view. But it is the worst format for sharing of data, where that data needs to be actionable and analyzable downstream. And it's such a pity that still PDFs is so common in our industry for sharing of data, not just reports.
Yeah, no, absolutely. Absolutely. So yeah, next up, not again. New ground insights keep derailing my design process. Anyone on this one? I know this is something that we've heard quite a few times come up, even internally at Fugro as well.
Yeah, I know that there's often we are asked to go back to a different site where we've been before, where they said, wait a minute, now that we know more about the site, can we reanalyze the situation? And we've been called back for further data analysis, which often is a change of scope and an increase of cost, and often at the delay of the project or the analysis of the site.
Exactly. Exactly. And then finally, another one in there, if only we knew this before we started designing. How about that
Yeah.
one? Does that one resonate with any of you? Yeah, Felix, again, yes, absolutely. Deborah, is anything you want to add there from insight side of things?
There's often
All
a lot
this,
of
yeah,
projects where that again we notice that comes back to the drawing board for further analysis and change of scope. And what we will discuss later in this presentation is it's actually even good that it's caught at design phase as opposed to not being discovered until the construction and even operation phase of the infrastructure.
yeah. No, absolutely. That's so true. Now, let's move forward. We want to talk about the agenda today and what we plan to cover. So first, what we're going to dig into is the importance of geodata and infrastructure design. So that's where we'll begin our journey, and then we're going to talk about achieving a single source of geodata. And this is where we'll do some introduction into GeoDin itself. And then finally, we want to talk about seamless geodata integration into design, and that's the importance of interoperability as a piece of that. And as mentioned before, we're going to leave some time for Q&A at the end, but along the way, if you have a question and don't want to forget it, feel free to drop it within the chat. Please don't hesitate. So with that, let's dig into the importance of geodata and infrastructure design. Let's start there. It's an important topic. So with this quote, we will likely spend more on infrastructure in the next 40 years than we have in the past 4,000 years. That's 100 times accelerated, which it's just wild if you think about it. And I know McKinsey had said the world needs to spend, I believe it was 57 trillion on infrastructure by 2030, which is 5 years away. Not very far away. So it's pretty impactful when you think about the investment that really is needed.
Especially considering that we have a lack of engineers and professionals that are experienced in the field. The amount of productivity and efficiency they need to do to execute these projects is incredible. It's actually a quite a staggering task at hand.
It is. It definitely is. Now, as we move forward with that, Devers, I want to hand it over to you because obviously it's costly, really not taking in to hand this geodata information. We have some good examples here, and I'd love for you to walk us through them.
Yeah. One of my favorite examples is, of course, this iconic Tower of Pisa. I always when I visit it myself and see pictures of it, it just reminds me of the importance of ground data. It's actually a building where geotechnical engineering has gone really, really bad, in the sense that the ground conditions were not properly analyzed at the time, and it has led to the ground being not suitable, the foundation being not suitable to carry the load of this iconic building and magnificent building. It's a marble structure for most of its elements. It's quite heavy, and it actually, even at the construction phase, it started tilting, and that's why it actually has a bit of a curve, because the engineers thought they could mitigate it by starting to construct it at the opposite angle, but of course that hasn't worked out really well either. And actually, when they did the analysis of it, the ground conditions, and they found out that lack of understanding of the geotechnical conditions was the cause of it, and the insufficient building conditions. Of course, here in this case, the boreholes were 830 years too late, I always say, because they analyzed it way after the structure is, and um, and it's been very costly to keep it from catastrophically falling over. The Italian government has spent about $30 million to date, and still counting, to make sure that there's no failure of the building. Of course, for this building, maybe that was compensated by tourist revenue because it was become an iconic site visit, but not always is that the case. And this cost is staggering to try to remedy structures going bad like this, when things like this happen. And the interesting thing I always find is that this is still happening. I mean, 1,000 years later, we still are getting it wrong sometimes, and it is a costly exercise at that. For those of you who are not familiar, this is the San Francisco Millennial Tower. It has been finished, I think, in 2008, 2009, and it has already sunk 18 inches and tilted 29 inches at roof level, which is a staggering amount for such a modern structure in this day and age. And they already have sunk in about 100 million and counting for keeping it from falling over in downtown San Francisco, which would be, of course, a catastrophic failure. And there's a lot of analysis and reports on it, and one of the theories behind it is that, again, the foundation and the understanding of the ground conditions to carry the load of this massive building was not properly accounted for, was not maybe done in enough due diligence in analysis, and the remedy that they're trying to do this is with extending of the foundations to a deeper level where there's bedrock and more stable ground conditions. Of course, it would have been a lot easier to do this at the early stages of the construction, as opposed to retrofitting and trying to fix the problem backwards, not to mention the damages and liabilities that comes with such an event.
It's so true. I mean, and as we think about this, that it can be costly, and even when it's actually in time, there's still a cost to that, and we see that as 28% cost overrun. Devers, from your perspective, and I know we've done research on this, where is that overrun coming from, and where are the areas of opportunity as we move forward?
This is actually a very good question. There's been numerous studies in all sorts of engineering magazines and project management courses around the world on it. This is an interesting one I picked up from the International Journal of Innovation Management and Technology, where they have done a global survey of project managers across the world on various projects. In this case, they actually looked at tunneling projects, which are, of course, very prone to ground conditions due to their nature. And the biggest cost contributor to the project was identified by far to be the geology in the ground. And the biggest cost reduction opportunity when they did this survey was mentioned as site investigation, better and more suitable and more clear site investigation plan. And when they looked at what made the biggest impact in hindsight on delays and overruns, they said insufficient information and investigation about the ground conditions up front. That is shared, documented, clearly available to the project team. And that's a staggering amount. I mean, this is a huge impact allocation that's often overlooked, and it's often a hindsight that this pops up, but actually it should be a foresight and thought about in the early stages of the project planning.
Absolutely. And obviously too, part of this is that there's a lot of cost associated with it, but when we don't catch things, as we kind of move to the side here, we see that it can be really catastrophic and it can come with grave consequences, lives to be included. Can you go over some of these examples?
I found this to be the most impactful, of course. I mean, we can talk about all the costs of fixing things during construction or during operation, as we've seen in the two iconic buildings that are trying to fix it after the building is open for operation. But what if you don't catch it? What if it's not a slow decline, but a catastrophic failure at some point? What I found interesting in this example is these are three examples of civil infrastructure failing in recent dates, in the last 2 decades, in three different countries where building codes are among the most stringent and strict. We're talking about Singapore, Norway, Sweden, and Austria, where everything is taken very diligently. Yet these incidents are happening, often with lives being lost, not just the impact to the failure. And a third of these sort of catastrophic failures in civil infrastructure, according to a European study, has indicated a third of them are actually linked to ground conditions being not properly accounted for or not properly being understood at the early stages of the design and construction phase. And yet the cost associated with understanding that and doing your due diligence would have been a tiny fraction of what the impact was here, and also preventing lives being lost and devastating impact happening.
Absolutely. No, and another thing to look at too, I mean, that is these are really surprising for sure, but we also thinking about sustainability, looking at the environmental side of things. And I know I was surprised, I didn't realize how much the construction sector accounts for global greenhouse gas emissions. It's about 21%, with cement representing about 10% of that. Um, can you talk to us a bit about this, Devrez? Kind of why is this the case? What is this coming from?
Actually, concrete and cement is very energy intensive to produce and to transport and to pour into the foundations. It's often overlooked. I mean, I think the transportation industry is and the energy generating sector is often blamed for or taken as the leading causes of CO2 emissions. But indeed, the construction industry is a big contributor also because of its scale. And you already mentioned like how much more construction and infrastructure projects are coming up ahead of us with all of the climate considerations also ahead of us. This is something we really need to keep an eye on. The production, the percentage of contribution is above now 10%. It has exponentially increased, as you see in this UN study, and there's a lot of room for optimization there because often the solution to uncertainty or dealing with ground uncertainty is to over-engineer it and build a bigger foundation just to be on the safe side because you don't know what the risk is or you don't understand fully the ground conditions. Actually, there has been a study in the Olympic project in London in 2012 where they have done their due diligence and done very detailed site investigation when they were building the Olympic facilities in the middle of London. And they were able to show that by doing better geotechnical analysis and more customized designs, they were able to reduce the foundation by about 25% and the length of the piles by about 10%, which is a huge amount of savings when you think about it, not just in terms of the investment cost, but also in terms of the carbon footprint of the project.
No, it really is. It's impressive, honestly. Um, Understanding the impact of not having this geodata or, things that can be related to it when you don't take it all into account and have all the information that we need. Devers, let's shift it. Let's talk about how hard is it actually to see what's beneath the ground?
Yeah, why do we still get it wrong after 1,000 years? You would have been thinking that we should by now have solved this challenge, and the challenge is actually the ground is just very variable, and it's very hard to know what it is, what is in there, and what the layers are. It's due to the nature of Earth that taking this example of a valley, for example, you can have all sorts of different soil conditions depending on where you are within the vicinity, and it can change drastically even over short distances of the location because The valley may have been formed by erosion. It may have been formed by soil coming in through alluvial depositions. There's different mechanisms of earth, and it's over millions of years this is formed, and the variability is very high. And you make all of these decisions about your infrastructure. For example, if you were to put a bridge here, where would you do the crossing? Where would you put the legs of the bridge? Where would you put your supporting structure? At the stages of the project where you know least about the ground by its nature, because you haven't maybe done your analysis, and those impactful decisions that you take early on in the project have a long longevity throughout the project, and it's very difficult to sometimes correct them backwards because you've taken a lot of decisions around it. Maybe you've started your sampling around it. Maybe you've started your excavation, and that's why it is very difficult to get this right. It's often the cause of overruns in projects when you actually encounter it during the project. It's usually a cost factor if you've completed the project and started using the structure, and it can even be catastrophic, as we saw it in the earlier examples. So it is a tough challenge.
It is. Speaking of the tough challenge, also perfect transition into really, thinking more about the geodata and how we deal with this ground uncertainty, because it is there, right? And it does cause challenges. So as we move forward, we look at this as two ways. One is achieving a single source of geodata, and two is the importance of interoperability, which, I mean, the industry is very vocal about this and really wanting to ensure that software solutions they use are interoperable across the board. Let's look at this visually and talk about the importance of those two things, having that single source of truth, also with integration as part of it. Can you talk us through the asset here, kind of starting through the process, Devrez?
Yeah. So typical life cycle of the project starts with an early feasibility study and conceptual design where you have a selected site, or maybe you have a couple of options which you have down selected to, and you sort of start doing screening around it. Sometimes geophysical screening, sometimes just a survey of the topography on the site. And then you sort of move into a more refined choice of, okay, here's where I think I'm going to put my infrastructure on. I need more detailed knowledge. So you start doing these detailed site investigations, as we call it, where you maybe do in situ recordings with CPT technology, drilling, sampling, laboratory, and bring those start to bring those results together to form a bit of a image around what is actually a black box when you start with it. And when you have a decision on where you would like to put your legs of your structure, or maybe you have a couple of options again, you start doing more detailed finite element type analysis on, how will my soil structure interaction be? How will the load be? What would be the optimum foundation to carry the load and be reliable and safe? And then you go into, of course, a detailed review of that and a construction phase, and then, of course, the operating phase. What you notice throughout this is the importance of geodata, even at the operating phase, from the feasibility phase all the way to the operating phase. Ground plays a big role because your structure is not sitting on air or perfect layer or strata. The ground is complex and it's also evolving over time as the structure is there. Maybe there are earthquakes, maybe there's subsidence, maybe there's some erosion. So ground is throughout the asset life cycle an important part of it, and geodata is a critical part of it. So what we always recommend is start with forming that picture very early on and stick to a single source of truth, because you will keep adding knowledge to that single source of truth as you do your analysis, as you do your excavation, as you do your construction. You will find out more about the ground you're dealing with, and you can keep adding to this database. And it's very important to work to integrate between a geotechnical, a geodatabase, and whatever you're using as a BIM infrastructure. In this case, for example, we work with Autodesk, and there's a lot of solutions about design and operation of infrastructure there as building information management systems. So you need to make geodata a key part of that, a key partner of the BIM model you have around operating the asset.
Right. No, for sure. And again, leading us really well into talking about first, before we tackle the interoperability and the integration, achieving that single source of truth for geodata. So this is where I'd like to introduce you, GeoDin, and talk about it a little bit. I know some of you on the call are already familiar, so thanks for your patience there. But just a quick overview of the background, because GeoDin, it isn't new. As you'll see from this title, it's been around 30 years, and it was created by geotechnical engineers who saw a need. They had this data and they had a headache, just like we spoke of before, these headaches that still exist. And they might have had a few different ones 30 years ago, but I think some are still pretty similar. And needing a solution where they could really store all this data, easily access it, and then also be able to visualize that data as well. So that's where GeoDin was born. And again, it's been around for a few decades now, and with that time has come many geo projects. We have over 15,000 where GeoDin has been used, many, many boreholes logged, as you can see. And we've been really fortunate to work with a variety of clients across the board, engineering firms as well as government too. And if you go back to the other slide really quick, Deborah, sorry, just because it's so funny, you see some of the older pictures of our team. Um, and we're so fortunate. Two of these folks in the photo are still part of our team. And I think that says a lot. We have a lot of tenure on our team, and they really know the industry and obviously Geodin very well. Now, Deborah, as we head to the next slide, we just want to talk a little bit more about Geodin into the details. So it's a robust database which allows you to really take all of that geodata and store it in one location. So then it's very easy to access. With that, we're compliant across 11 international geotechnical standards, and it really allows you to get a good data structure and consistency of your data. So then you can properly pull reports. It also helps, of course, with being able to visualize and really just having that clear view of your geodata. It is really giving you that ability. Um, we have some visuals here on this side. Devers, I don't know if you want to add anything to these visuals. I know we'll have more coming up.
Uh, Maybe just briefly, what you see on the left side are some examples of the diversity of data we can store, and we'll come back to more examples of that. But GeoDin is quite a flexible product in terms of structuring your geotechnical data. And sometimes we underestimate the complexity of ground data. It can vary from, the data that you acquire can vary from in situ data, which you record continuously as you probe the ground. In this case, on the upper left corner, for example, what you see is a cone penetration test result where you record multiple parameters every 2 centimeters. That's quite an intensive recording of data that we can bring into GeoDin. And on the lower left, you can also combine this data into analyzed strata and interpreted results, where you
Tabii ki
see
application logarit.
analysis of your results where
Hmm.
you have identified the layer descriptions, the parameters, the interpreted results, and you can also store those. So GeoDin can cover from very early site data all the way to interpreted and analyzed results.
Thank you. Thanks, Deborah. It's very helpful. Now, I want to go into a bit of an example for you where that GeoDin has served as that single source of truth for geodata. This example is coming out of Germany, and this was a national power line, and it was going all the way from the north of Germany, so where the renewable energy is with wind, all the way down to the south, where it would be utilized industry-wise. So it's over 700 kilometers of underground cable, and when we look at the site investigation, Fugger was only responsible for, I believe it was 100 of those kilometers. Am I right, Devrez? It was about 100?
Yeah,
Yeah, and
roughly.
so roughly. So you have all of these companies, as you see at the bottom, also doing site investigation. And so GeoDin served as that single database, so that single source. And as you can see, there are many soil samples brought in as well into GeoDin, with it being heavily accessed by each side of the project as well. So yeah, Deborah, is anything you want to add to that?
No, the interesting thing for this project was we were looking at some really interesting parameters around thermal conductivity of the ground, for example. Actually, that is a very important parameter when you're designing an underground cable, which is carrying many high power, high voltage and high amp power lines, because you want to make sure that you utilize the most out of your cable line without it going into failure due to overheating. So you look at heat dissipation parameters. So there's a lot of different types of parameters you can look at during your infrastructure design. And this one is a completely different one than what you would do for a bridge design or a tunnel design, for example.
Exactly. It's very unique. And speaking of that, let's go through some other visualizations because obviously there's more to GeoDin than just databasing. Also, the visualization piece is really important. Like you talked about, like heat map visualization. Devrez, if you could speak to these, I know we have a few here and on the next slide, and kind of how they're able to visualize their data within GeoDin.
So indeed, once you've sort of gathered all of this data, whether that be on-site data or later laboratory analyzed data, or whether that be photographs, as you see here, for example, we can store sample photographs that are taken on-site to scale as they have dug through the ground. You can bring all of that into scaled models and scaled reporting in various templates, depending on how you would like to visualize it, for which stakeholders you would like to visualize it. We have a very rich template database that can host these, and you can even customize those to your company's needs or to your standards in the markets or in regions that you operate in. On the right side, what you see are, for example, the detailed compenetration test results that I mentioned. Those are those squiggly lines, which are very dense in information, and then they are later analyzed and turned into soil classifications based on the multi-parameter analysis. And those are also integrated into the software so that you can do these with established standards and established empirical correlations at a few clicks only.
Great. And then if we go to the next slide too, yeah, we can talk about cross sections and then again, the heat map visualization as
Yeah.
well.
So if you have a parameter that's distributed over your site, whether that be, I don't know, water content, for example, or geo risk parameters, you can actually visualize it on a heat map to identify areas which you would like to already discard as options for certain passing throughs or certain elements and of your infrastructure. And also very useful, what our users usually give feedback on being very useful is cross sections, because you want to be able to visualize along the track of your road, railway, bridge, whatever your infrastructure is, what the ground condition variability is that you will encounter as you're digging through. And you can overlay the surface topology with the layers identified, as well as individual boreholes that are mapped and visualized. And you can have all of these in large reports that you generate for a given site, for a given project.
Great. Thank you, Devrez. And now let's talk a little bit about how do we bring this single source of truth to designers, right? So the geodata is where it needs to be for that part of the design process with integration. Devrez, let's talk a bit now about interoperability with GeoDin. First, I'll start and just saying that it really is part of our fabric at GeoDin is really making sure that we're not a closed software, that we're really open to integrating with others, allowing for this interoperability, whether it's how you decide to store your data. I mean, it could be local to your PC, it could be network, it could be in the cloud. That is something that you really get to decide. And one thing that's really important for us as well is that your data is yours forever. We don't access your data. We don't use your data. It is yours. And that's something that, we really hold true to. It's been for 30 years and we'll be continuing that for 30 plus more years ahead. Another big piece to this too, when we think about making sure that we are interoperable is with Ghent sunsetting, really ensuring that our clients that are coming over have a way to easily ingest their legacy information into GeoDin because Devrez, just as you said, all of this information as we look over the timeline is really important, right? And you really want to be able to pull back into that data as needed. So we've created a Ghent conversion tool bringing over that legacy data, working really closely with clients one-on-one as well to ensure that their data comes into GeoDin. And, of course, some of this data, it's 20 years of data. It could be even more than that at times. And so that is something that is very important to us.
This data, as you've seen, is very difficult to acquire, and it therefore is very valuable to the asset owner often. So the extra effort to make sure that data has longevity is a very valuable investment. And one thing I'd like to add is with our infrastructure or the way we have set up the software, it's actually technically impossible for us to access the data because the database is not hosted on infrastructure we own and operate, unless the client specifically asks for that, in which case we can do that. But most of our clients actually in this day and age prefer to manage that infrastructure for hosting the data themselves, because there's a growing concern about the importance of geodata, especially in this day and age where there's so much geopolitical tension around the world. And the value of underground data, asset data, where it is, how it passes, how deep is it buried, is becoming actually a critical piece of information. And countries around the world are starting to forbid operation of or storage of geodata outside of their national servers. Examples of this are countries like Japan and Middle East, where sensitivities around geodata is really being taken very seriously.
Yeah, for sure. And even, within North America, be it the US or Canada, we're seeing this as well with some of our prospects that we're speaking with about GeoDin, is that this is really important for them, the data residency piece, because of the sensitivity of projects that they're working on. So really great call out there, Devrez, on data residency and the importance. Um, with that here, now talking about even more on the interoperability side and how we really get that information into designers' hands. First, let's look at the status quo. What does it look like today, right? So right now, when we think about how the geotech team is able to get data to the design team, it's really very siloed. A lot of this speaks to the geotechnical headaches we asked about before with PDFs. A lot of it, as you can see, is shared within PDFs. And obviously, that's not ideal. Even from a security standpoint, things can be forwarded very easily when it's in a PDF and things are sent via email. And so at this point in time, as you'll see, it's very disjointed, right? It's very disjointed and it's really very cumbersome. So much so that many times the design team, even in the end, may have no idea what's beneath the ground. Even though the geotech data is there, it's really hard for them to access it. And then from the other standpoint, sometimes it is really nice for the geotechnical team to know, all right, what's going to be built on the ground where we're doing this research and pulling this data. So when we look at it now, there are many headaches causing a lot of insufficiency and also some security concerns in there as well.
Yeah.
And now let's look at kind of where we're taking this journey, right? As we kind of step forward, and that step forward with the data exchange, right? Really giving more flexibility where you have this export import capability. So you're able to not just share in PDF, but export it from something like GeoDin and then import it into, say, Civil 3D in this example. So really helping to alleviate some of the pain around that, where your data isn't corrupted in that sense. It's seamlessly coming over and ending up where it needs to be. Granted, not seamless. There are some steps along the way, but seeing some of those headaches alleviate.
Indeed.
And then
And
Devrez,
we've
take us a
released,
step farther. Yes.
yeah, indeed, and we've taken steps on that from our side, right? In the recent years, because our clients have been asking for this. Moving away from PDFs has been a big theme for us for several years now. Where we've released recently a DXF export, for example, one of many export formats we've released, but this one in particular resonated with our clients because they were able to bring in geotechnical reports directly into their design environment, because DXF is a very common format for design of infrastructure planning, and infrastructure overlay management. So they could ingest this data, put it into context, put it as part of their design documents, and have it at their fingertips already. And this was an important step forward. And this also has been so appreciated by our partner, that we became a close strategic partner to Autodesk, because we can do these sort of integrations with their platform. And we've taken actually that to another level as well, because not only do we generate and pull over the digital borehole into the design environment, but we've also done an export and import functionality where we can bring in the borehole model as a whole, with all of the metadata around it, be it coordinates, be it the strata definitions, and bring that into the design environment, where then you can use the design environment's powerful capabilities around visualizations and 3D modeling to visualize the ground together with your infrastructure. And that's already an important next step as well. One of the things that these sort of import-export functionalities already solve is the errors that were happening on which borehole are you looking at, is the coordinate correct. These sort of metadata aspects are taken care of automatically, because we make sure that we export with the right coordinates around it, the right metadata, the right layer descriptions, and it comes into the design environment if you take your precautions right, with the right coordinates attached to it. So that already eliminated and solved quite a few pains for our clients.
Yes, Devrez. And then we can see, how does this play into what we've shown you before? It's kind of an evolution, if you will. And with this direct integration and that interoperability, it really makes it possible for early design decisions to be solid, because they're based on the latest geotech data. They're able to take all of this into consideration, which of course leads to more efficiency, projects being more on time, saving cost, and also avoiding those catastrophes like we talked about in the beginning, which are really important. So you can see that there's a flow now where, again, of course, far away from those PDFs, which is where we want to get. I know that's still going to take time, because that's something that's still very prevalent to this day. But really allowing, through that data going into a single source of truth, and then being able to directly integrate into the design platform, Civil 3D in this instance here, it really allows for that kind of peace of mind, less errors, more safety and security as well. So it's really a nice seamless flow. Then, Deborah, just to take it a step further, let's talk about in the next slide just the process of that. Before I do, though, we are very fortunate to be an Autodesk partner in this. I do want to highlight that. I forgot to mention it in the slide prior, but we have a partnership with Autodesk, especially as we look at the Civil 3D integration. We work very closely to make sure that we keep it updated and also have a lot of customer feedback. Let me pause there, because Deborah, your team's done a lot on that, but I'll hand it over so you can talk through this, and feel free to add anything I might have missed there on the partnership.
Yeah. What we wanted to do with that partnership, and we've been working closely with them, is to remove the import-export completely. I mean, we've sort of pushed the envelope limits on that as far as we can, but that is not ideal, because it's still asynchronous. You don't know when the last export was done, when the latest import was done. Is that the latest one you have? Is this the correct one? Were you supposed to be sharing that or not? So what we've taken it is a direct integration approach, where your design environment can now connect to your geotechnical database, to the GeoDin database, with the right access, authorization and authentication, security environment around it. And you can consume the GeoDin data directly from the database into your design environment at moments that you feel you need to do that syncing. And you know that you're looking at the latest version, because it's a live link there. And when you bring that sort of rich database into the design environment, it opens up a lot of doors for the design team, for the consultants, and even for the on-site team that may be looking at the same Civil 3D file in this case, for their construction planning, for their site investigation planning, or any project planning that they may be doing. So we've taken that sort of approach now, and we've released our beta plugin that lives in the Civil 3D environment. It's just a toolbar on top, which allows you to ingest, view the database, select the projects you have access to view, select the boreholes that you're interested in ingesting. You don't have to ingest the whole database if you're not interested to do so. You can if you prefer. And then you get the metadata around it, as well as the borehole models that are generated for those locations, as well as, and we're adding every day new data types to be ingested in there. You have more and more rich data coming into the Civil 3D environment. And now you can also use the Civil 3D's functionalities to generate surfaces, to generate volumes, and really visualize the ground in a rich and understandable way. I'll give you a quick glimpse of how that works and through this movie, which is sort of gives you a flavor for how that integration is actually operating. So you have all of this data. In this case, this is a rail station in the US where you've done your site investigation. You have all of these descriptions of the ground through the layers. And you go over to your Civil 3D environment. You fetch these locations through. And what do you see? You get those sort of circular site analyzed information with all of the descriptions around it, the metadata, its location, its depth, its thickness, the soil descriptions there. You can select a portion of them and say, generate me a surface, generate me a volume, and you can even then hide specific layers. Maybe you don't want to see the limestone, maybe you're focused on the chalk layer, maybe you're focused on the rock layer, and you can sort of start visualizing it and working with that data together with your design. Because you can put your infrastructure on it and understand the implications of your infrastructure and what interferes between your infrastructure and your business objectives around the infrastructure and the ground. What are the risk points? Here, for example, you have that rail station going through, and you can even see where do you need to do excavation? What type of material do you need to excavate? How much volume you need to move from that location? And if the geotechnical analysis provided you with the density of the material, you can even calculate how many tons of a certain element or certain material you need to dispose of as part of your project. So it really comes together in a very powerful way, and you can make decisions around this because you can then say, okay, what if I had my rail track over there instead of over here? What if I move things 100 meters? What does that mean for my construction? What does that mean for my costs? Maybe the tunneling cost, maybe the material moving cost, excavation cost, or risks associated. Would my foundations be shallower because I have bedrock on this location closer to surface? I would have to do less maybe concrete pouring. That's where that sustainability angle we talked about comes in. So having that ability to look at that data and make judgments on it very early on in your design process can really make your process much more efficient, much more time effective and cost effective, and you will be taking these critical decisions we talked about earlier with informed, accurate knowledge.
Great, Devrez, thank you. Thanks for giving that overview. It's always nice to have visuals. Hopefully for you on the call, it's nice to kind of see what it looks like and have that walkthrough. Let's talk about, so we don't want to stop here, of course. We're really very excited about this direct integration. But Devrez, let's talk a little bit about the other data sources that we're looking to connect as we move into the future.
Yeah, indeed. We start with the borehole models and soil descriptions as they are stored and analyzed inside GeoDin. But there's a lot more that we feel we can do. One of the things that we're going to release, for example, soon is water content and laboratory results being available at the fingertips of the designers, because often you take samples at critical locations, send them for analysis. Those reports often come back into the GeoDin database. We will make that insight and those analysis reports also available inside the design environment. And one of the things that we are, for example, imagining and looking forward to having is that feedback loop as well. As the design evolves, the site investigation program can evolve. As opposed to having and that one-time layouts being a site investigation plan having laid out according to your initial thoughts on where you were going to do the construction. As you make decisions on, I want to move the construction, you may actually request new site investigations, and that will be a closed loop. It will make it a lot more lively. The geotech team will know how the design is evolving, and the design team will know how the ground is becoming clearer every day. So we really see a lot of opportunity around this.
No, for sure. And we're excited. We've been getting a lot of feedback too, which we really believe in and really helps us for the end users that are, as Devrez mentioned, testing out beta version of it too. You know, what's missing that we'd like to see in there so we can also plan for the future and see what makes sense. And speaking of the future, I don't want to interrupt this because this is an exciting one as well.
Yeah, we started with geotechnical data and 2D and taking those sticks and connecting them and forming a picture of Earth. But of course, we know that the future is actually scanning technologies. I mean, this is very akin to the medical industry where they went from doing biopsies in the past to actually doing MRI and CT scans before they do the biopsy. So they know, they have a feel for what is peculiar, what is normal and what's peculiar, and they only analyze the uncertain parts of your to take a biopsy on. And the future for ground investigation is the same. There are a lot of technologies that are developing rapidly, and Fugro is also part of those, to scan the ground and form a 3D seismic image of the ground before you do site investigation. And that allows you to direct your site investigation to the locations where uncertainty is high, or geo risk is high, or locations of interest based on your earlier insights. So we're working very hard also to bring in 3D data into GeoDin and make it available to the design process as early on as possible.
No, this is great. Devrez, thank you. I know this gets me very excited as we think about the future and possibilities. So you all, thank you. I know we've been talking for a long time, but the good news is we got through our agenda. We talked about the importance of geodata, the importance of having that single source of truth, and then the importance that integration, well, that makes a difference when you can bring it directly into design, leaving, leading to much more efficiency and just better overall security and less catastrophes as well in that process. So with that, we want to say thank you for your time. And this, I know we don't have that much time, but we certainly want to give at least 10 minutes for anyone that's available to talk through any questions that you have. Feel free to drop them into the chat, the Q&A area, or feel free to come off mute as well. I don't know if you can hear, but I think that should be possible for you to come off mute. However you feel comfortable, please do so. And as for Devrez and myself, please feel free to contact us as well. We can drop our email addresses into the chat. Eric, I see you're typing in there, so I'll now wait patiently in case there are questions. Okay, great. Eric, thank you.
Thanks
And
for the
thanks for
feedback.
joining us. I'm going to put my email in here in case you have any questions. It will be in the chat. Yes, Rajat, great question. We will. We'll be sharing a recording of this session with you.
I think it will become available on our website.
Yes, you're right, Devrez. It will.
And I saw an earlier question about the slides as well. I think we can make those available as well.
Yes, we will. Yes, I think, Thomas, that might have been from you. Yes, I put a thumbs up there, but I thank you, Devrez, just so we confirm, we will definitely share those slides with you as well. Pekka, thank you. Thank you for joining.
And you're welcome to also
Yes.
just go to geodin.com and download a trial of it. And we do have just free downloads that you can do. You can also get sign up for the public release of the Civil 3D plugin and sample data sets around it. If you would like to understand and work with some sample data, we're happy to provide that and do a more deep dive around it as well.
Yeah, for sure.
Thomas, for sure. There's definitely CPT interpretation and reinterpretation tools in GeoDin. That is possible. We have all of the standards like Robertson classification tools, analysis tools, all of the established methods around analyzing CPT are part of the toolkit of GeoDin desktop application. So if you have a specific need, please drop me an email. Let's explore what you would like to do and whether that is available or how we can make it work.
Yes, please do. And Eric, I see that you said the session is also available on the Autodesk website. It is. We did a similar, not almost the same presentation at Autodesk University back in October. So yes, it is accessible there, but we'll also make it accessible as well on our website too. See. I was just responding. I know Felix wasn't able to respond in chat, so use Q&A to say thank you. Um, Beyond that, too, just to follow up with what Devrez had said, we do encourage you to do a trial of GeoDin. It is really the best way to get to know the software, and we always like to give, if you're open to it, a little bit of a overview, 10-15 minutes before you jump in, so it gives you a little bit of a starter and where to go for some of the common things that you would be doing in the software. So you'll see I dropped the website in there, so please do take a look. If you're interested in a trial, you can sign up right on our website on the first homepage there, and then you have my email address as well as Devrez's for any questions. Please don't hesitate to reach out. We are very approachable, hopefully you can tell, and happy to talk through GeoDin and any questions that you have.
Thank you for attending.
Yes, thank you.